Thank you so much, sir. On behalf of Vignan University, we are glad to be here, sir. You and our students from robotics, they have a few queries about MEMS topic.
Good afternoon, sir. Myself, Saitya Jaswini Rao, fourth year robotics. I'm from Maharashtra, sir. Sir, coming to the question I want to ask you is with AI and emerging IoT these days, so how does MEMS, as a real time program, come into this emerging in real smart devices, sir?
Thank you. And to start with, thanks for inviting me to Vignan University. It's been a great experience so far. And I think it's an excellent question. MEMS is a technology. So you can apply a technology to pretty much any application that it is suited for. And MEMS is no exception, right? So you have a technology where you're miniaturizing mechanical systems, and it's up to us to find applications. So IoT is a classic fit for something like this because MEMS deals with sensors and actuators. For example, if you're shopping online, and today you can browse various products, you can read reviews, and you can purchase things online. The next level of experience could be if you are, let's say, buying a dress. Can you have a touch and feel of that object right at your computer? That is one big aspect of IoT, right? Something that will give you the sensation of actually being at a physical shop and having that touch and feel of that fabric. And that may make or break your decision to buy it, right? So in those kinds of applications, this could play a big role. You could imagine even perfumes where you may want to smell it before you buy it, right? So that extra sensory experience that comes along with a purchase, just in this example, right? There could be many, many more examples of IoT. Even if something as simple as I want to have an online meet. Today you have Zoom or Teams or so many tools for that. And I want the experience of a physical presence, which means, for example, before the meeting starts, I want to shake hands with that person. Today you can't do that in an online meeting, right? So these kinds of sensors and actuators, which are the two halves of MEMS technology, could aid things like that. So those could be very interesting applications of the future where you use sensors and actuators to create a live experience. Today you can only see and hear the person, but you can't do anything beyond that. So that beyond part is what MEMS could enable.
Good afternoon, sir. Myself, KSS. I am from robotics and automation from second year. My question is, how the MEMS technology is very important in India, and what are the key challenges in fabrication?
So another good question. India doesn't have the lead in this technology. So unfortunately, we were a little late in the game. So even if we make a good sensor, for example, using this technology, then there could be a pushback from the market or from the customer saying that, why can't I just buy an equivalent German product, which has been in the field and it's proven for many years. So we have to fight that. And the way to fight that, in my opinion, is to get creative on brand new applications of this technology, right? Rather than repeating and relearning and reinventing the wheel, right? There's nothing wrong in doing that for the sake of learning. You can repeat and reinvent if that helps build the skills here. But to make a difference, we have to dream up a brand new application that other countries who have a lead on this technology have never dreamt of. And I think we have the brains. It's a question of bringing the right brains together and focusing them and putting them on this job. So that is something that India should do if they want to have a lead, not just in this technology, but in any technology where we are lagging, right? A disruption has to happen in thought and in implementation. And the other question I think you asked is challenges in fabrication, right? So there are many technical and commercial challenges. It costs a lot to set up a fabrication facility to do this. And these MEMS type fabrication facilities are not exactly compatible with semiconductor fabrication, though that was the origin. The semiconductor fabrication facilities expanded into these kinds of fabrication capability. So it's one step, in some sense, one step less than semiconductors, in some sense, one step more advanced than semiconductors, for example, in terms of the materials used and all that. So it is, to me, that part is a question of will and the question of people to be able to fund some facility like this. But that will and the ability to fund comes with a business case, which means you have to be able to churn out products in scale, in volumes. Because only when you have that kind of scale, the cost will come down and you have the ability to compete and sell these products. So it kind of works backwards. Can you have a business case to have these kinds of fabrication facilities in India versus just buying them from somebody else, right? And that will, if you have that business case, that will in turn drive funding. Money is available, but money has to be channeled into the right areas. And that right area depends on which areas have the strongest business case. And there are technical challenges as well. And I alluded to a couple of them. For example, materials are exotic, more exotic in MEMS, right? And some of those materials are not compatible with traditional electronic fabrication facilities. I mean, for example, some people say materials like gold cannot even come near semiconductor electronics fabrication facility. So there are examples like that. So there are technical challenges, and there are further technical challenges in the sense that these are processes where you build these things layer by layer, or to some extent you can dig into the substrate and build some larger kind of structures. But core mechanical engineering builds parts and assembles them. But this is a different kind of build philosophy where you print just like electronics, and then you etch, and then you carve out structures. It's like some of the temples in India where you start with a rock and you carve out a structure out of it and you get a statue or even the entire temple, like the Ellora temple sometimes. MEMS is like that. You have a base silicon and either you stack something on top of it, that's one stream, or you carve stuff out of the silicon and make a mechanical structure. But given these constraints, making a three-dimensional structure has some limitations. So that's a very technical constraint in MEMS fabrication. Whatever you do in the macro scale, where you make parts out of various machining processes, casting processes, etc., and assemble them, you don't have that level of flexibility in the micro scale. But you have certain other advantages.
Good afternoon, sir. Myself Suriteja. I am pursuing robotics and automation in BTech, 4th year, sir. I am from Warangal, sir. Sir, how can students can get some hands-on experience in MEMS, and like, can you recommend any projects, any tools, or any software, sir?
Hands-on experience can happen in various different facets. So there is the design, how you design micro-mechanical components or systems. So that's one aspect, and that's classic design. Many simulation tools are available to do mechanical simulations. You have to find something that does electromechanical simulations, where the electrical properties of the materials are also taken into account in the same model. After design, you have the fabrication, which means that you need a clean room and you have to make it. There are facilities in India where you can send your design and they'll make it for you. Right? Of course, if you can build your own clean room, there's nothing like it. After that, there is the packaging, which means that you have made a machine in a small piece of silicon, and you have to be able to interface it with other systems, like electronics for readout systems or whatever it is. And ultimately, it may have to go on a PCB. Right? So there is that step that goes from the bare silicon post-processing to an actual package, which means it looks like a chip with some pins coming out on the sides where you can connect it. That is actually a very interesting field of research because, for example, just to explain this in a very simple manner, if you want to package electronics, you will put it in a plastic case and you will protect the electronics from the environment. All you need is to make the electrical connection, so you have these pins coming out on the side and on the ICs. In MEMS, it becomes a very difficult proposition because if you take a sensor, for instance, you cannot just protect it from the environment because you have to expose it to the environment for that at least that one quantity that you're sensing. So if it's a pressure sensor, it has to feel the pressure. So if you just package and protect it, it won't feel the pressure from the external ambient. If it's a temperature sensor, it has to get hot when the ambient gets hot. Right? So sensing and packaging of sensors is a very challenging and therefore interesting area. So where you have to protect the chip from the bad things, but you also have to expose it to that one quantity that you're sensing. So it's a very exciting field. And there too, you can start with existing sensors, or you can team up with sensor companies, and you can explore ways to package. The same sensor may need a different package for a different application. For example, if I'm using a pressure sensor here, it can be a pretty simple package. But if I'm using it inside the deep sea, where it's salt water and it's corrosive, that will need a different kind of packaging. Right? So the challenges make this problem interesting. And finally, beyond packaging, there is testing. So you can choose to say that I'm going to take existing sensors and I'm going to develop capabilities to test these things so that I connect the sensor to various real-world applications. So that testing function, and it's not easy to test these devices all the time because they are very small, and you have to understand the limitations and the good things about these sensors. So developing these testing capabilities and therefore connecting these to actual applications is also a pretty powerful thing to do. So there are many, many ways to explore your own personal interest in topics like these. And you can pick and choose in terms of what you like to do.
How important is it to have interdisciplinary sectors in MEMS technology, sir?
Yeah, I think that's the foundation of MEMS. If you look at where MEMS exists in many colleges, universities, you will find it's not in the same department across these universities, right? So in one place, it will be in mechanical engineering. In some other university, you may find it in electrical engineering. Somewhere else, you may find it in material science. Somewhere else, you may find it in physics or applied physics. So by definition, it's an interdisciplinary field. And I think that's why there is so much left to invent, because you can intersect any of these disciplines between mechanical, electrical, materials, physics, and so on. And you can figure out new ideas. So there'll be a lot of sparks that will fly in when you discuss these topics, right? And there are unlimited, literally, applications depending on how you can play these intersections to innovate. Having said that, people who intentionally and make it a point to study multiple disciplines and end up in a field, for example, like MEMS, are typically winners because they can think across these domains and they can therefore make their career more successful because of that.
With your extensive research and patents in MEMS, like what is the most complicated project you have done, sir?
So most complicated, most proud, most impactful, it's all the same answer. So when I was working for GE General Electric, I proposed, started, executed, of course along with a big team, a project on mechanical replacement for power electronic devices. And I showed part of that in my talk today. So power electronic devices, the fundamental component is usually a switch, which has to switch the power back and forth. And we thought that originally switches were mechanical, and then the field of power electronics came in, and then people saw the benefits of electronic switches, namely fast switching, mainly long life, right? And that opened up a huge set of applications. And we realized that we can actually go back to the mechanical domain because of these new technologies like MEMS that are available, and in fact gain advantages over electronics. So we realized that a mechanical switch fundamentally can have much lower losses, which means it's much more efficient. We realized that it can have much lower leakage, right? So for all those reasons, mechanical actually made sense. And if it can capture the advantages of electronics also, which is high speed and high number of cycles, reliability, then all the more, right? So you're marrying the world of older mechanical switches and the newer electronic switches to create a new technology of switching, which I think has a distinct advantage and has a high probability of replacing power electronics as we know it for a set of applications. There may be still a set of applications where electronics still wins. But I think this is something that is very powerful. So when I was working for General Electric, I started this project. It went very well. And at a time, this project team spanned 4 different countries. And literally one team across 4 countries working on this project. And was very well funded. And this project is now spun out of General Electric as a separate company now. Just because, among other reasons, they also realized that the applications of this technology is not just captive inside the company, but also goes beyond that. And there could be many other people who can use it. So it was a very exciting time in my life. But I also, at that time when this spun out, or a little before that, took the decision to come back to India from the US. I was doing this in the US just because we wanted to be in India.
What are the key applications we can use in all the industries like healthcare, automobiles, and consumer electronics, sir? How can we use MEMS technology?
So I think there's a lot of literature out there. In fact, these applications are very prevalent today. The most classic ones are the accelerometers that are used in automobiles that trigger the airbag. So when there is a crash, it detects it and it triggers the airbag. There's also gyroscopes which detect rotational motion. If you take consumer electronics, the sky is the limit. For example, in many countries which don't have enough sun like we have in India, they have a clothes dryer. So you have a washing machine and then from there you take the clothes and put it into a dryer which gives you completely dry clothes. The washing machine gives you half dry clothes and this one will give you fully dry. So I'm just picking this as an example, just as an everyday use case. That dryer will have a humidity sensor, which is the only way for it to tell whether the clothes are actually dry. Because the clothes are tumbling in the air and it's hot air. And when the air is humidity, because air is what's picking up moisture from the clothes, the air's humidity goes below a certain level, then it knows the clothes are dry. So very simple use cases which can use sensors of this sort. We spoke about projectors in the talk where you have these mirrors which work out. Medically, I think there is so much left to do. I mean, there is no limit on what you can do, which is personalized treatment. And I'm pulling up medicine because somehow I feel that that is the area of science where we have a long way to go. We only have a surface level understanding of how life works and how the human body works. And there is so much that we can do, and there is so much gap in terms of what the population needs, in terms of curing medical diseases, improving health conditions, and so on. And we have not even scratched the surface. So plenty of applications. I can talk for 2 hours on this, but any field you pick, as I said originally, it's a technology, and it's up to us to devise an application for this technology to pretty much any field that exists today.
Sir, in your point of view, what is the next big revolution that will be upcoming and will take a huge place in MEMS technology?
It's a very tough question to answer because if I knew the answer, I would be doing it. So again, I think I would revert back to my previous answer because where is the biggest gap? Right? Yes. Medical and just the knowledge of life and the human body, both to explore that knowledge and understand it, and also on the other side of the same coin, cure issues that come up like diseases. To me, that is a topic that I don't fully understand. I don't think anybody fully understands, and that is why it's my favorite topic, because there is just an unlimited number of things that you can do. I mean, you can hopefully in the future cure diseases like cancer, right? I mean, if you have bots which are going around in your body and identifying those cancer cells one by one, if they're doing all the hard work for you and eliminating them, then there's nothing like it, right? So I'm sure there are many more applications left to happen in other areas as well, like consumer appliances, mobile phones, automobiles. If you take mobile phones, for instance, you would think you have a great mobile phone today, right? But you would think that what else can you do in a mobile phone? Because pretty much everything you want is already there. You have calling, you have internet, you have, I don't know, video calls, you have radios, you have YouTube. What else can you do in a mobile phone? Maybe a mobile phone can tell you what the air pollution is in this room. Maybe it can diagnose diseases for you, right? It can do what's called prognostics, which is predictions of what might happen. It may tell you that if you have a samosa in the afternoon every day of the week and go to sleep late at night, then you're going to develop acidity, right? So there are, again, it's all your imagination, right? So one topic in mobile phones could be more and more sensors. Today you can measure some basic things in your body like pulse rate and some stress level and stuff like that. But I'm sure there'll be a day where you can do a complete ECG, complete blood work, right? And test if somebody has tuberculosis or malaria or something using a mobile phone, right? So there is definitely more left to happen, and MEMS will be the enabler for all this. Just because, not that there are no other great technologies, but it is the technology, and it's on a chip. And it's the technology that interfaces to the outside world and to the human body, and it is something that is at heart a mechanical or a chemical or a biological chip. So if you want applications in mechanics, chemical, biological, this is the answer, naturally. So again, I don't know the single point answer for this, but I think there are just too many to list. Right? And we can keep on dreaming about new applications. The point is to pick something and focus and say that this is what I will work on, and this is something that's going to have a big impact. Like if you take automobiles, for instance, can I improve battery technology through some micro devices like this, right? Because today for electric vehicles, battery is the biggest pain point, in the sense that it adds a lot of cost to the vehicle. It's also heavy, right? And you have to keep charging it. It takes a long time to charge it. So it's the biggest pain point. So you can take that as a need in the market, and you can find out how to use these technology tools, not just MEMS, but in any other tool you have at your disposal. It could be MEMS for certain functions. It could be AI for making some sense out of the data you get from these sensors. And then you could apply it to solve this problem. I am a big fan of that. I love to find the requirements first and then work in reverse, backwards, to figure out what technologies need to be deployed to solve that problem. The other way is a more difficult way, because you may work on your favorite problems, but they may or may not have real-world applications. So if you work backwards from real-world applications, at least if you are successful, then the application is waiting for you.
When can I expect the driverless vehicles from Ashok Leyland, sir?
That's a huge question. I don't know the answer, right? We are working on lower levels of autonomy, which is called ADAS, Automated Driver Assistance Systems. So autonomous driver to me means you can replace the driver. Driver assistance means you can help and support the driver, right? So the first set of technologies that will come out would warn the driver. I mean, some of this is already there. You can warn that somebody is coming too close to you. You can warn that if you keep driving at the speed, you're going to hit somebody. Next level is you warn and you take some action, right? That will also come soon, where you say that there is somebody too close to you in front, and therefore the car automatically decides to hit the brake, either fully or partially. When I say car, it could be car, bus, lorry, whatever. So another level is you're giving, there is something called lane departure warning. If you're driving on the highway and you drift into another lane and there is a higher risk of an accident, you first give a warning. Next level beyond that is the car automatically turns the steering to keep you in that lane. So there are steps towards autonomous, right? And that's what we are working on. Ultimate autonomous today may make sense even today in certain controlled environments, like within a port, airport or seaport, right? Where the traffic movement is controlled, the rules are clear, and people actually follow the rules, right? There may be a higher chance of bringing autonomy versus bringing full autonomy on an actual open road. Yeah, so there are various steps, but you also have to ask yourself, do you need autonomy? Everywhere, right? Somebody may like to drive, so, and that person may not choose to have autonomy. Somebody may say that the ethics is an issue. If there is an accident in an autonomous vehicle, who will I blame? Right?
For logistics, Ashok Leyland big vehicles also.
Correct. For logistics and stuff, especially with the drivers becoming more and more scarce, it may make sense, right? We don't know. I mean, I don't think anybody knows the answer whether full autonomy is required in all these vehicles and when it will actually happen. But we are experimenting with it. And we are experimenting and deploying much lower levels of autonomy, which is driver assistance systems. Yeah.
Thank you.
Thank you.